talking about graphing calculators. And the important thing here is how these things can be used to help you. But you are going to have portions on your test. You're not allowed to use these things. An important thing to remember about graphing calculators, you should this in your notes. If you don't have this particular thing starred or something in your notes, I'm going to give you a 0 for it. Watch window sizes. This is very important. You want to be sure to set your window sizes so they show enough detail. Too big a window may make two functions look like they are intersecting when they're not. Okay, also if you don't have the right window size, you're not going to see anything on the function. What the window size is something you're going to have to learn to play with, and you're going to have to learn to set on your own at this point. Okay, on the TIs that you guys are dealing with, we need a y equals format. Now, you have something on your, and if you remember right, well, let's take a look at something. Well, you've got something called Grapher, and we're going to take a look at it here in just a second. On Grapher, you don't need this. When we go back in and take a look at this, what you should see as I do this is going to look like in Algebra 2 when we had we were graphing circles and ovals. We had the y1 and y2 equals, if you remember that little thing. Okay, so let's take a look at x squared plus y squared equals 9. This is a circle. If you do this on a TI, you're going to have to solve this thing. X squared equals 9 minus, or y squared equals 9 minus x squared. Y then is going to equal 2 plus and minus 9 minus x squared. And so in the TI, you're going to have to put this in as y1 equals the positive square root of 9 minus x, and y2 is the negative square root of 9 minus x. However, if you come back in and take a look at Grapher, which would be in your application section, I would strongly recommend you put Grapher up in your doc. So I'm going to come in up here. And I'm going to graph the equation I had. Which was x, there's a caret here somewhere, squared This is not behaving nicely. So I'm going to have x, then you use a caret, 2, and then you want to space over, plus y caret squared equals 9. And the reason that didn't go over is because I didn't use my arrow keys to get out of my power. And there's a circle. As you can see, we didn't have to solve it. It's centered at 0, 0, has a radius of 3. I would strongly suggest you start playing with Grapher. Okay, the other thing you're going to deal with TIs is they will be able to find points of intersection for you. Do not ask me where to find these. I'm not going to tell you, except right now. They're under the calc button. Go in there, look, and find it. They will find points of intersection. They will also find zeros, which is where your function equals 0. These are also your x-intercepts. Recall it said x-intercepts, zeros, and solutions can be very, very similar. Okay, let's take a look at how you can actually use these things to solve. So you need to solve this guy. Okay, now this is a simple little Algebra 1 problem, but you can actually put this in your calculator. You do y1 equals x minus 4. y2 is what's on the other side of the equation, 5x plus 12. You put that in, and then find the intersection. Okay, another thing this will help you with is things like this guy. Now we're going to show you how to do this without the graphing calculator, and you're going to have to know how to do this without it. Okay, so what you do is this is going to be your y equals. Okay, then you go to calc. Zeros, and then you enter the left bound, in other words, the left side of a 0, right bound, and your guess. The closer you can get these to where it actually is graphically, the sooner the calculator will do this. Okay? And this will come right back in, and it will give you then where the zeros are of this thing. This can also be used to solve some nasty little inequalities. For instance, x cubed minus 3x minus 10 is less than or equal to 0. Okay, now in inequalities, make sure they equal 0, okay, like we did with quadratics. So what you do with this now is this is your y equals. You find your zeros, okay? The solutions are where the curve is above the x-axis, which is why you need to find your zeros. That's where it goes above and below it, and that gives you your bounds. So what you're going to end up with is bounds on where these things are. Okay, a left bound and a right bound.